Hi, welcome back to my YouTube channel. If you're new to this channel, my name is Abdul Wahab Animoku and I'm a college maths instructor. And in today's video, we're going to look at a calculus problem which has to do with finding the local maximum and minimum values as well as saddle points of a function of two variables. So let's just get right into it. Now, there are several steps that we need to take in order to be able to find the maximum and minimum values. And it's a little bit analogous to functions of single variable, right? But it's a little bit of twist and turns here. So we just get started and look into the details of how to solve such problems. Now, the first thing that you have to do is to find the partial derivatives. So the first partial derivatives, you need to find those so that we can get the critical points. So the first step is to get the critical points for this function. So these are called critical points. Sometimes interchangeably, you can say stationary points, right, of this function. Okay. Now, how do we get that? We get the partial derivatives, which means the derivative with respect to x as well as the derivatives with respect to y, and we equate those to what? Zero. So this is the first. We need to solve these two set of equations to be able to find the critical points or critical values for this function. Now let's find this. So f of x, fx is basically the derivative of this with respect to x, and we have a polynomial function here, so we know they're differentiable everywhere, so we can just quickly find the derivative of that. So the derivative of a constant is 0. The derivative of minus 2x is going to be minus 2. Derivative of 4y will be 0 because y is looked at as a constant when you're differentiating with respect to x. So this part will be 0. And here we're going to have difference. Derivative of this is going to be minus 2x, and of this is going to be 0. Now, if you're not familiar with derivatives of polynomials, you have to know that if I have f of x that is of this form, the derivative of this with respect to x is giving us what? N x raised to power n minus 1. And that's what I'm using in differentiating, for example, this term, where a is minus 1, n is 2. As you can see, a is minus 1, n is 2. And when you find the derivative of that, you have minus 1 times 2, x raised to power 2 minus 1, which will give us minus 2x. All right. So basically, f of x is going to give us minus 2 minus 2x, and that will be equal to 0. In similar fashion, we would find the partial derivative with respect to y, which is going to be the first time will be 0, second time will be 0, third time will be 4, right? The derivative in the fourth term is 0 because we don't have y on this term. And finally, the derivative of this one is minus 8y equal to 0. Now, when you solve these two equations simultaneously, what you have is that from the first one, you would get 2x must be equal to minus 2 when you take 2x to the other side. And then this gives us x equal to minus 1. Secondly, when you look at this second equation, you basically have 4 equal to 8y, which means y equal to 4 over 8, which is 1 over 2. Now, it means the critical points that you have is when x is minus 1 and y is minus 2. Okay, perfect, perfect, perfect. Now we have the critical point. Now we have to determine if this critical point is a minimum value, maximum value, or a saddle point. Okay. Now that comes the second stage. Now in the second stage, the first thing that you have to do is to find the second partial derivatives, right? So which means we need to find f of x, fxx, fyy, and fxy. And I think the first one is easy because we're going to find the derivative of this fx, right? That's how you get f f the second partial derivative with respect to x. We need to find the derivative of this one more time, which is derivative of what? Minus 2 minus 2x. And derivative of minus 2 is 0. Derivative of minus 2x will give us minus 2. Perfect. And what about fyy? That would give us derivative of this one, which will be 0 minus 8. So it's going to be minus 8. And what about f of xy? We could use this f of x. Then now we have to differentiate this with respect to y. As you can see, there is no y here, so this will give us 0. Okay. Now we have this second partial derivatives. Okay. Now from here, what's the third step? The third step is to figure out the values of these partial derivatives with respect to the critical points that we have. So we need to now calculate So if you have more, if we have many critical points, we have to do this for all the critical points, right? So you can see that what these values are constant, they don't depend on x and y. So basically it will be the same thing. Because they don't depend on x and y, you basically have the same thing for each critical value. Let's say you have 10 critical values, it's going to be the same function for all of them, right? The same values for all of them. Now that you have this, now the third step is to consider a function d of x, which d of xy, which depends on this partial derivatives and is calculated as this square. Now, for each critical point, you need to calculate the value of d of that critical point. So in this case, d of -1, 1/2, this will give us -2. Remember, we have -2 here, -8, -8, then -0 square. So this gives us 16, and this is positive. Now, what does this second derivative test do? So this is how we classify the critical points using this test. Now, if d of xy is greater than 0, and at the same time, the second partial derivative with respect to x is, let's say, is less than 0, then we have this critical point xy would be, so this is negative, so it's concave down, so it's going to be a maximum. The same thing, if this is greater than 0 and the second partial derivative with respect to x is greater than 0, this would give us a minimum for that xy. And if we have this to be less than 0, this implies a saddle point. And finally, if d of xy for that particular critical point is 0, we'll say no conclusion. That means we have to find other avenue to classify that point. Okay, so so basically when you look at this, this is greater than 0. What about f of x with respect to -1 and 1/2? This is what? -2, and this is what? Negative. Now using this test, this means that what? This point must be what? Satisfies the first condition, so it means it must be a maximum. So this implies that what? This value for f of xy. Okay, so you can basically substitute this -1 and 1/2 into the function to calculate that particular maximum value. So you can do that. You can do that as your classwork. Now, in the next problem, we'll be solving another problem similar to this, but that will be more computationally intensive than this one. So stay tuned for that. Make sure you watch this video again to make sure you have the second derivative test under your belt before you go to the next video. So I'll see you guys on the next one.